Yeah, then I pack the make it closer, make it closer. Yeah, it's fine now. Yeah, just try to put it a little bit closer. Is it coming out nicely? It's fine. Is it audible? Just checking. Hello guys, I'm back. I had problems with the sound. Guys. I had problem with the sound. I think we can start now. I had problems with the sound. Can you hear me? Can you hear me? I had challenges with the sound. Can you hear me? Can you hear me? Can you hear me? I had challenges with the sound. I had problems with the sound. Can you hear me now? Just confirm. Give me a thumbs up if you can hear me. I had challenges with the sound, guys. Sorry for the delay. Sorry for the delay. I had problems with the sound, but I'm back now. Sorry, guys. I had challenges with the sound. Today I can't stream on both YouTube and TikTok because of a technical challenge. I had problems with the sound. So I'm back now. So let's see. I'm back now. Let's see if we can get to 100, then we can start. We can get to 100, then we can start. I'm seeing 50 now. Please accept my apologies. Sorry. Sorry for the delay, guys. Sorry for the delay. All right, sorry for the delay. I think we can start now. Let's just get to 50. I've got 31 now. Let's get to 50. I see we have got 41 now. Let's get to 50, then we can start. Let's get to 50, then we can start. Okay. Let's get to 50 so that we can start. Thank you so much. If you can hear me, please give me a thumbs up. We are going to start now. So the first thing, guys, when you are doing your map calculations, so the first thing that you should check is your scale. I'm going to do the scale conversions. That's what I'm going to do. For your, right? Or before we even go to scale. So what we are going to do today, let me just start just with an introduction of what we are going to do today. Here's what we are going to do today. We are going to do map coding. That's what we are going to do first. Then after that, we are going to do calculation of distance. Then after calculation of distance, we are going to calculate gradient. After calculating gradient, we are going to calculate our area. Then after our area, we are moving on to true bearing. After true bearing, we are going to calculate magnetic declination. After magnetic declination, we are going to do magnetic bearing. Then after magnetic bearing, if time permits, we are going to do our vertical exaggeration. And lastly, intervisibility. So that's what we are going to do. So what I usually do, or what I usually encourage my learners whenever we are doing map calculation, is to write the scale of your two maps. That is your topographical and your orthophoto map. That is your topographical. This is your topographical map. You can see this is your topographical map. This is your topographical map here and your orthophoto map. You already know about this. So we are going to write the scale first for our topographical and orthophoto map. So for the topographical map, and here I'm going to write for the orthophoto map. Orthophoto map. The scale that we have for the topographical map, I'll show you, then I'll also write it on the board. So for our topographical map, the scale that we have, if you can check here, you can see it's 1:50,000, which is 1 centimeter on the map represents 50,000 centimeters on the actual ground. So this is the scale for our topographical map. That is 1:50,000. Remember, all these units are in centimeters. These units are in centimeters. So this is for your topographical map. I'm just going to show the scale first before we start with the calculation. You have to know the scale of this map, okay? So that is your ratio scale for the topographical map. Okay, so this is the ratio scale for the topographical map. All this is in centimeter. 1 centimeter on the map represents 50,000 centimeters on the actual ground. So you can be asked to give your answer in meters or kilometers. So what I usually encourage is the first thing that you have to do the moment you get your Mapwork paper is to first write the scale for both topographical and orthophoto. So here we have put 1:50,000. So I want us now to convert our actual distance on the actual ground into meters. So how do we go about it? How many centimeters are in 1 meter? 1 meter, we have got what? 100 what? Centimeters. So for us to convert this 50,000 into meters, we divide by 100. It means we are going to say our 50,000 centimeters divided by 100 centimeters. What are we going to have here? Okay. So it means it will be the same as 1:500 meters. So what we have changed, the map on the distance on the map still remains in centimeters. The distance on the map still remains in centimeters. What is only changing is the actual distance. That is what is only changing, the actual distance. So here we have the same scale for our topographical map, but here we have converted it to meters. So this is the same thing, which means here this is the scale in centimeters. This is the scale that we have converted now in meters. So what is changing is only the actual distance on the ground, which is we have converted our 50,000 and we have converted into meters. So here is 1 centimeter on the map represents 500 meters on the actual ground, but now it's in meters, okay? Then what we are going to do, we are going to further convert it into what? Kilometers. How many centimeters are in a kilometer? That's what we need to know. So we have got about 100,000 centimeters. So which means our 50,000 centimeters, we are going to divide by what? By 100,000, okay? That is 100,000. Let me put another 0. 100, okay. That is 100,000, which means this one, this one, this one, this one. Then we are going to divide, which means we are going to have 0.5. That's what we are going to have, which means it will be equivalent to 0.5 what? Kilometers. So what we have done, if you can check here, we have converted our scale for the topographical map. The first thing that we have done is we have converted first it in centimeters. 1 centimeter on the map represents 50,000 centimeters on the actual ground. And we have said now we want to convert the actual distance on the ground to meters, which means we are going to write it now in meters. That will be 1 centimeter on the map represents 500 meters on the actual ground. It's still the same scale, but with the different dimensions. Here is kilometer, here is meters, and here is kilometers. Okay. So for our orthophoto now, what do we have? I'll finish this, then I'll look at your comments. For the orthophoto, if you look at this, you can see it's 1:10,000. That is your orthophoto. That is the scale. So it means we are going now to write, the first one is 1:10,000. Okay, 1:10,000. And remember, this is in what? in centimeters. This is in centimeters. 1 is to 10,000. And we have said our 1 meter is equivalent to about what? 100 centimeters. So it means we divide our 10,000 centimeters, okay, we divide it by 100. What are we going to have? Which means we'll have the same scale in meters as to 1 is to 100 meters. That's what we are going to have. Same applies. We have said our 1 kilometer is equivalent to what? 100,000 centimeters. So it means we divide our 10,000 here, divide by what? 100,000. Okay, which is, okay, so which means our 1 centimeter will be equivalent to 0.1 kilometers. Okay, so this is the first thing that we have to do. This is the first thing that we have to do. We have converted our scale. We have converted our scale from centimeters to meters and also kilometers. So you can have a multiple choice question that asks you to the correct scale for the topographical or the orthophoto map. So if it's in meters, it means now it is changed from 1 is to 50,000 centimeters to 1 is to 500 meters. If it's orthophoto, change from 1 is to 10,000 centimeters to 1 is to 100 meters. That is in meters. And if you have got an answer that is in kilometers, it means now you have divided your 50,000 by 100,000, which gives you 1 is to 0.5 kilometers. Yes, 1 is to 0.1. So I want to hear from you. Do you understand how I have converted the scale from centimeters to meters and kilometers? Do you understand how I have converted the scale from centimeters to meters and kilometers? Can you give me a thumbs up if you understand, so that I can move on to the calculation? So this is the first thing that I've done, okay? I have converted. It's the same scale. You can have a multiple choice question that asks you about the scale of a topographical map, but it can be in kilometers or in meters. So you should know this. This is the scale for both the topographical and the orthophoto map. Okay, someone is saying, I don't understand. Okay, don't worry. I'll just explain it in brief. Someone is saying, I don't understand. All right. Let me just explain for the last time. Is there another option to know all of them? Okay, so guys, what we are saying is we have got here on the map, this is our topographical map. I'm just showing only the scale. It's 1 is to 50,000, which is a ratio scale. So we are saying now you can have a multiple choice question that asks you about the scale of a topographical map, but the options that are given are not in centimeters. So that's why we have converted into meters and kilometers. Okay, so what did I do now? I have started by writing this ratio scale. As you can see, this is what you can see on a topographical map. 1 is to 50,000, which means 1 centimeter on the map represents 50,000 centimeters on the actual ground. So this is what you get on the map. This is what you get on the map here. This is what you get on the map. 1 is to 50,000 and 1 is to 10,000. This will be on a topographical map, and this will be on your orthophoto map. This is what you will get on the map. But you can have a multiple choice question on your question paper that asks you to choose the correct scale for a topographical or orthophoto map. Let's say we don't have the one that we know, the common one, that is 1 is to 50,000 in centimeters. And the answer is written, say either in meters or in kilometers. What we have done is we have converted our actual distance, which is 50,000 centimeters, into meters. How did we do that? How many centimeters are in a meter? It's 100 centimeters. So we have divided 50,000 divided by 100. That's how we got this 1 is to 500 meters. So it's still the same scale of a topographical map, but the difference now is this is in meters. We have also done the same thing. We have converted our topographical map scale to kilometers. How did we do it? We have looked at how many centimeters are in a kilometer. It's 100,000. So I have divided 50,000 by 100. That's how I got the 1 is to 0.5, which is 1 centimeter on the map represents 0.5 kilometers on the actual ground. That's how I've done it. Same applies with your orthophoto. You have got your scale 1:10,000. This is in centimeters. So what we are changing is only the actual distance on the ground. So we have also done the same thing. How many centimeters are in a meter is 100. We have divided our 10,000 centimeters by what? By 100. That's how we got 1 centimeter on the map represents 100 meters on the actual ground. That's how we got this. Okay? Same applies if you look at here. I have also converted into kilometers, which means our 1 centimeter on the map is equivalent to 0.1 kilometers, which means now all these scales for your orthophoto map, they are the same. The only difference is the unit of measurement. Here, the actual distance is in centimeters. Here, the actual distance is in meters. And here, the actual distance is in kilometers. But it's the same thing. Same applies with your topographical map. This is the actual distance in centimeters. This is the actual distance in meters. This is the actual distance also represented in kilometers. That's the only thing that we have changed. So all these is the same. The only difference is the unit of measurement that has been used. But our scale for the topographical still remains 1:50,000 centimeters. Same applies with our orthophoto 1:10,000 centimeters. But you can have a question that has got options or answers in kilometers or meters. So you have to know how to convert all these. So what we have done now is we have now, if I'm to rub it off, we have this. Okay, we have this. This is what we have. This is what we have, which means we have now a 1:, let me rub off this so that I can write it one after the other. This is your map. So the first one, we have said we have got 1:50,000. This is in centimeters. Then into meters is 1:, this is 500 meters. Then 1:0.5 kilometers. So take note, these remain in centimeters. The only thing that is changing is the actual distance on the ground. Okay, same applies here. We are saying is 1:10,000. This is in centimeters. Then here is 1:100 what? Meters. Then here is 1:0.1. This is in kilometers. So what is changing? The unit is only the actual distance on the ground, which is 1 centimeter on the map represents 10,000 centimeters on the actual ground. 1 centimeter on the map represents 100 meters on the actual ground. 1 centimeter on the map represents 0.1 kilometers on the actual ground. On your topographical map, 1 centimeter on the map represents 50,000 centimeters on the actual ground. 1 centimeter on the map represents 500 meters on the actual ground. 1 centimeter on the map represents 0.5 kilometers. Are we together now so that I can continue? Are we together now? Some of you guys were saying that you are confused. Are we together so that I can continue? Is it fine now? Is it fine now? So that I can continue. Is it fine? Can you give me a thumbs up if it's fine? I think it's clear now. So let's start now with map code. Let's start with map code. I think that's the first thing that I'm going to do. Map code. Okay, sharp. Let's start with map code. I'm going to rub off this. We'll come back to this when we are doing calculations. You already know about it because I've explained. So when it comes to map code, guys, map code, that is the first thing that we are going to do. Map code. All right. I'll show a map, then I'll work with what I have on the map. So we are going to start with map code. So this is what we have. Can you look at what we have here? I want you to look at where it's written. Extract from 3026 DA Alwal. I'm going to write it on the board. Extract from 3026 DA Alwal. I'm going to explain what it means. I'm going to explain what it means. Okay? Are you ready? I'm going to explain what it means. Extract from 3026 DA Alwal North. I'm going to explain what it means now. Okay. So, extract from 3026 DA Al-Wal North. Okay. Al-Wal North. Okay. I am only concerned with this. Okay. This is what I'm more concerned with. That is the map code. That is 3026DA. That is what I'm more concerned with. So your first 30, it represents the latitude. Your first, the 30 represents the latitude, which means we are looking at it like this, 30 degrees. Okay. Then your 26 degrees, it represents the longitude. Then your D, it represents the bigger block. Then your A represents the smaller block. Okay, the smaller block. So that is the first thing. Okay, so I'm going to demonstrate it on the board now. So we have something like this. Okay, we have something like this. Okay, all right. So this is going to be your 30 degrees latitude. Remember, the latitudes are horizontal. Then vertical, that is your longitude, which means this is your what? Your 26. Okay, so what usually happens when they are doing maps, they divide a grid into 4 bigger blocks. They do like this, okay? 4 bigger blocks, which means we have got block A, block B, block C, and block D. So from what we have, it means now this is our latitude here. This is our latitude. Okay. And the 26 is our longitude. Is our what? Longitude. Then the D, this is our D here. Our D here is the bigger block. So what they do after this, they further divide each bigger block into 4 smaller blocks, which means we are going to end up with something like this. Which means in A, we have got 4 smaller blocks. We have got A, B, C, and D. In B, we have got A, B, C, and D. In C, we have got A, B, C, and D. In D, we have got A, B, C, and D. So now, we have got our latitude 30. We have got our longitude, which is 26. We have got our bigger block, which is this D in red. The whole of this, that is your bigger block here. That is your bigger block D. Remember, we started with A, B, C, and D. That is your bigger block D. So the smaller block A now, what is it? The smaller block A is this. That is your smaller block A. So what this means is, this map now that we have of Al-Wal North, the map that we have of Al-Wal North, the one that I'm holding here, it was taken from a bigger map. It was extracted from a bigger map. That's what it means now. That's why here it's written extract from. So it means from this bigger map that we have, it is only this portion that is shown. That is your DA here. That is what is shown on the map. So when you look at the map of Al-Wal, the way it is here, the 30, 26, 30, 26 DA is an extract from, which means it was extracted, taken from a bigger map. That's what it means. So we have our 30, 26 DA. It's here. This is the part that is shown on the map, the one that I've shaded. So the question can ask you, what is the map north of 30, 26 DA. The map that is north of 2630 DA. If you can check, of course, here is the north, there is your south, east is here, west is there. What is to the north of 3026 DA is what? Is 30 to the north. We have got 30, latitude remains the same, 26. What do we have to the north? You can see now we have got BC. That will be BC. That will be the map that is to the north, because we have got our 3026 DA being here. So what is to the north of DA is the C here, is the BC. It is BC. That is what is to the north of 3026 DA, is what? 3026 BC. So that's what we have to the north. If we are going to look at what we have to the east, what we have to the east of 3026 DA, this is your DA. East, remember, is on your right, which means it becomes what? 3026 what? DB. That is what is to the east. If they ask what is to the south, your latitude remains the same, longitude remain the same. Obviously, to the south of D, what is at the bottom here? We have got what? DC. So that's how you do it. I don't know if you have got any questions. If you have got any question, do we all understand? Do we understand this one? Do we understand, so that I can move on? Do we all understand this part? Do we understand this part of map coding? Is there anyone confused? Is there anyone confused? Someone is saying, I don't understand. Yes, we do. Anyone confused? Anyone confused? Anyone confused, so that I can do it for the last time? Then we move on to calculation of distance. Anyone confused? Anyone confused? I've seen one saying that they are confused. Okay, no, sir, please repeat. I'm going to repeat. It looks hard. I can't understand. No problem. I don't understand. I'm totally confused. No problem. I'm going to do it again. What else? What else? What else? All right. I'm going to do it again. I'm going to do it again. Okay. I'm going to do it again. Okay. So please repeat. No problem. I'm going to do it again, guys. No problem. I'm going to repeat. Don't worry. We are not rushing. This is for our prelim. So we have to take our time to make sure that we understand that once we covered Mapwork, we know that everyone understands Mapwork. So I'm going to rub it off and start again. I'm going to rub it off and start again. Okay. I'm going to rub it off and start again. So, guys, when it comes to map code, okay, what I'm saying when it comes to map code, I want you to look at this. This is the map that I'm using. Extract from 3026 DA Alwal. Can you look at this, guys? So I'm going to explain the map code that we have there. That is 3026 DA. That is what I'm going to understand. Okay. Can we all see this? Extract from 3026 DA Alwal North. Do you understand this, guys? I want to start explaining. Can you all see this? Give me a thumbs up if you can all see this. Okay, give me a thumbs up if you can all see this. I'm waiting for the thumbs up. If you can all see this, I'm waiting for the thumbs up. Okay, can you all see this? Thank you so much. So we are saying, I have written it here on the board, extract from 3026 DA Alwal North. So what I'm going to explain now is what is the meaning of these numbers. 3026 DA. Okay, you know we do the coordinates when we want to look at when we are georeferencing, when we want to show the position of the location of a bit of cities or of things on a map. Okay, so we are saying now our 30 here, it represents what? The latitude. That is the first thing. 30 represents the latitude. Then 26 represents the longitude. Whenever we are georeferencing or when we are writing the coordinates, we start with the latitude, then the longitude. Do you understand this part? So our 30 shows the latitude and our 26 shows the longitude. Are we together? Are we together? On the latitude and the longitude, give me a thumbs up if we are together. Give me the thumbs up if we are together on the latitude and longitude. I need your response, guys, so that I can know whether to continue or to keep on explaining. Are you following? So we are saying our 30 represents the latitude and our 26 represents the longitude. Are we together? Okay, sharp. Then our D, the first letter represents the bigger block and the last letter represents the smaller block. That's what it represents. Let me draw now the grid with those blocks now. Okay. So we are saying now, we have something like this. This is the grid. This is your latitude. This is your latitude. So here what do we have? We have latitude, which is what? 30 degrees. We have vertical longitude, which is what? 20. Let me just give a different color, which is what? 26 degrees. Are you following? Then our grid is divided into 4 bigger blocks. It means now, for our grid, we have got something like this. 4 bigger blocks. It's the same grid, but it's divided into 4 bigger blocks. That is A, B, C, and D. Are you following on this one? Are you following? So we have got our grid that has been divided into 4 bigger blocks. So we have got A, B, C, and D. So D is your bigger block. Are you following? D is your bigger block. Are you following? Are you following? Give me a thumbs up if you understand. sorry. So D is your bigger block. Are you following? Can I continue? Sharp. It seems like you are following. So our bigger blocks are further divided into 4 smaller blocks, which means for each bigger block, that is A, B, C, and D, is further divided into 4 blocks. Okay. So we now have something like this. We now have something like this. Okay. So our A, it has got A, B, C, and D. Our B has got A, B, C, and D. Our C has got A, B, C, and D. Our D has got A, B, C, and D. Okay. Are you following this part? Are you following? So we have further divided our bigger block into 4 smaller blocks. That's what we have now. Can you see what I have? If you are following, please give me a thumbs up. If you are following, give me a thumbs up. If you are following, give me a thumbs up. Are we still together? Or some people are lost now? Are we still together? Sharp. So we have got the latitude, which is 30. We have got the longitude, which is 26 degrees. Then we have got our grid with bigger blocks A, B, C, D, the one that is written in red. Then we have further divided each bigger block into 4 blocks. That is A, B, C, and D. That's what we have done. So what it simply means is our bigger block D is this one. That is our bigger block. Bigger block D. That is our bigger block, which means the whole of this is our bigger block. But we are not yet done, because we want to highlight the smaller block. Our smaller block now is A, which is this. Okay, so what it means now is this map that we have of Alwal was extracted or taken from a bigger map, and the only part that is shown is this that I have shaded in black. So that's why it's written extract from 3026 DA Alwal North. So it is only this part that I have shaded here, which is your DA, the one that is called the smaller block. That's what is showing what we call Alwal. So I said now after this, we have got now 30, 26, DA. So a question can ask you, It can be multiple choice. They can ask what map is. What is the map code north of 3026 DA? North of 3026 DA. What is the map? So what you do now, your latitude remains the same. Your longitude remains the same. Okay, but you now have to check here. This is your DA. What is to the north? What is to the north is the sea, and the sea has got a bigger block B, which means now what is to the north, the latitude remains the same, the longitude remains the same. Is going to be now 3026 what? BC. Is going to be 3026 what? BC. All right. Do you understand how I got the code of the map north of 3026 DA? Do you understand how I got the map that is north of 3026 DA from the answer that I've written on the board? Do you understand now how I got the map that is north of 3026 DA? Do you understand? Yes, Mener, of course, I can see yes, I can see yes, I can see yes. All right, I want to hear from you now if you understand. All right, what is the map east of 3026 DA? What is the map that is east? Okay, I want us to find the one that is east. Remember, I said the latitude remains the same, which means we are still going to have 30 and 26. So what is to the east of 3026 DA? What will be the answer? Remember, your north, your south, your west is there, and your east is there. So what is to the east of 3026 DA? What will be the answer? What will be the answer? What is to the east now? Of 3026 DA, what is to the east? All right, I'm seeing it's DB. 3026 DB. That's correct. 3026 DB. You guys are cooking. It's DB. Remember, the bigger block starts first, so it's D first, then B, because B is on the eastern. B smaller block is on the eastern side of DA, so it becomes what? 3026 DB is DB. All right. What is to the south now? What is to the south? 3026. What is to the south of 3026 DA? What is to the south now? Sorry, guys. What is to the south now? Yo, Pindulo, you're cooking. DC, that's correct. 3026 DC. That will be your DC. All right. What is to the northwest? What is to the northwest now? Let's now look at the northwest. 3026. What is to the northwest? Northwest. What is to the northwest of 3026 DA? What is to the northwest? Wow. AD. You guys, you are cooking. You are cooking. That will be your 3026 AD. That is AD. 3026 AD. AD. What is to the northeast? How about the northeast? The northeast now? AD, that's correct. How about the northeast? The northeast, what will be to the northeast? Northeast now? How? Okay, someone is asking, how is it AD? All right. AD, northwest, check here. We are saying 3626 DA, north-south, northwest, which means it's this one. That's why it's AD. That's where the AD is coming from. Because northwest, here, AD. To the northeast, what will be the answer? To the northeast, what is the answer? BD. That's correct. That's correct. So, to the northeast, that will be 3026 BD. Okay, so are we all fine with map code? Are we all fine with map code? So that we can move on to the calculation of distance. Are we all fine with map code? I think this one, when it comes, I think all of you are going to get it right. Are we all fine with map code? Map code. I think I've explained enough, guys. I've explained enough. Please, if you don't understand, I think I'm going to upload this also on our YouTube so that at least you can go through this. I think I've explained. We have taken more than 10 minutes on this one. Yes, we are fine. I think I've explained this one, guys, in detail, This is a detailed and simplified information. Remember, simplified FET geography is here to simplify things. Let's move on to calculation of distance. Okay. All right. So the next thing that we are going to talk about is the calculation of distance. All right. So we are now going to look at distance. Okay. So distance is equal to map distance multiplied by scale. So this is the formula. Map distance multiplied by the scale. Map distance multiplied by the scale. Map distance multiplied by the scale. So what is important, guys, is the map distance is what you are going to measure with the ruler on the map. I'm going to demonstrate with an example what you are going to measure with a ruler on the map. All right. So I'm going to measure something here with a ruler on the map just to demonstrate. So I want my answer to be in meters. Can you take note? And I'm using a topographical map. So whenever you are calculating distance, one thing that they do is they tell you answer, all right? Answer, yes, to be in meters, okay? And use what? Topographical map. So these are the instructions that we have. Your answer has to be in meters and use a topographical map. So let's find out what we can calculate here. Let's just find out what we can calculate. I'm going to measure the distance between two spot heights. Okay, I've got two spot heights here. I've got spot height 1421 here, 1421 here. You can see I also have spot height 1412. These are the two spot heights that I have. So I'm going to measure the distance between the two spot heights. That's what I'm going to do. And I want to write my answer in meters. So how do I go about it? I take my ruler, then I'll measure from here up to there. Can you see? What do we have? I want you to tell me. What do we have here? It looks like we have got something like, to me, it looks like 2.5 centimeters. It looks like 2.5 centimeters. I don't know if you can be able to see it nicely. It looks like 2.5 centimeters from here up to there. It looks like 2.5. Can you confirm? It looks like 2.5 or 2.6. So 2.5 centimeters. So that is our map distance. That is our map distance. Okay. So it means our distance now, our distance, which is D, all right, let me write it nicely. Our distance is equal to map distance multiplied by scale. So our map distance, we have it as 2.5, 2.5 centimeters. Which map are we using? We are using a topographical map. So we are going to multiply. Okay, we can use 2.7, it's fine as well. 2.6 is fine, not a problem. All right, but let's just use 2.5 for just so that at least we use one thing. But it's fine, 2.6, 2.7, but let's use 2.5. Remember, there is always an allowance of 2 to 3 millimeters. You still get your answer is correct. So what is our scale? Remember, we said we are using a topographical map and we want our answer to be in meters. So what are we going to multiply with the map distance? We are going to use a topographical map. So what are we going to multiply with for our map distance? What are we going to multiply with? I want you to convert this scale into meters. That's what we are going to multiply with. Convert this scale into meters. Is 1 centimeter on the map represents 50,000 centimeters. Let's convert this into meters. Do you still remember what we did? That was the first thing that I did. No. 0.5 is kilometers. It's 500 meters. So it's 500. We are going to multiply with 500 meters. Do you all understand why we are multiplying with 500 meters? Do you all understand why we are multiplying with 500 meters? Exactly 500. Do you all understand why we are multiplying with 500 meters? We have divided the 50,000 by 100 because they are 100 centimeters in a meter. We have divided by 100 centimeters, okay? Because they are 100 centimeters in a meter. So we have converted the 50,000 centimeters into meters. So it means we are going to multiply our 2.5 by 500 meters. Okay. This is by 500 meters. Do you all understand this stage? Do you all understand this stage? Do you all understand this stage? Okay? Do you all understand this stage, guys? Are we together? Do you all understand this stage? Can we move on? Give me a thumbs up if you understand this stage. Okay, give me a thumbs up if you understand this stage. I want a thumbs up. Yes. Yes. Anyone confused? I think we are fine. All right. So now we are saying our 2.5. Let me get a calculator. What is our answer now? 2.5 centimeters. 2.5 centimeters. 2.5 centimeters. That is 2.5 multiplied by 500. 2.5 multiplied by 500. What is our answer? It will be 1,250 meters. That will be our answer, which is 1,250 what? Meters. So take note, guys, when you are doing the calculations, make sure your map distance has got a unit of measurement. Make sure your scale have got the unit of measurement. Make sure your answer have got your unit of measurement. Then you get your 3 marks. So each and every the map distance, unit of measurement in centimeters, the scale, unit of measurement in meters, and the answer as well, unit of measurements in meters. Remember, we have said that we want our answer to be in what? In meters. Do we all understand this? Are we together, guys? Are we together? Are we together? Anyone confused? Are we together? Are we together? Okay. Are we together, guys? So we are saying now, we are supposed to make sure that each and every dimension has got the correct unit of measurement, but the units are not the same. What are you trying to say if you are saying the units are not the same? Which units are not the same? We are all good, not together. Okay, which units now? Let me see, which units now? But the units are not the same, centimeters and, okay. Remember, no problem, I'll explain that. Remember, when we are looking at our map, all right, which is also 500 meters, okay, which can also be 0.5 kilometers, okay. So when we are calculating, I get you. This is your map distance, it remains in centimeters. This is your map distance, it remains in centimeters. What is going to change only is the actual distance, which means your answer, unit of measurement, will be affected by the unit of measurement on the actual ground. That's what we are measuring when we are calculating distance. So the unit of measuring on the actual ground, which is our scale, that is 500 meters. This unit of measurement will determine the unit of the final answer. We don't use this. This is representing what is on the map. We are more concerned with what is the actual the real distance, That's why we have got our answer in meters, because this is what is on the map. Are you following? This is what is on the map. So you multiply the map distance multiplied by the actual distance. Remember here we say 1 centimeter on the map represents 50,000 centimeters, which is converted to 1 centimeter on the map represents 500 meters. So we have measured our map distance, which is 2.5. And we are multiplying by the scale that we have converted to meters to give us the actual distance. So the unit of measurement that will be used by the final answer is what is on the actual ground, not the map distance. That's why we have got 1,250 meters. That's why we have got 1,250 meters. Is it clear now? Is it clear? Is it clear now? There's someone who are saying, we have got, is it clear, guys? So what affects the unit of measurement is the actual distance, which is our 500 meters that we have there. So that's the unit of measurement that will give us the correct unit of measurement for the what? For the distance. Are we together? Are we together, guys? Are we together, guys? If you understand, please tell me so that we can move to gradient. Can we move to gradient? Can we move to gradient if you understand? Okay, can you move to gradient if you understand? Okay, sharp. Let's move on to gradient. I'm going to wrap this off. If we all understand, distance is the easiest one. Okay, so we are moving on now to gradient. Okay, let me erase. So the next thing that we are going to do now is we are going to calculate gradient. All right, we are going to calculate gradient. Basically, when you talk about the gradient, we are talking about the steepness or the gentleness of the slope. So we are looking at our slope as to whether it's steep or gentle. That's what this is all about. We are looking at it, is it steep or is it gentle? That's what gradient is all about. What is the formula? So our gradient is equal to vertical interval. Vertical interval divided by the horizontal distance. In some books, they call it horizontal equivalent. Horizontal distance or horizontal equivalent. Equivalent. Okay, so you have to know the formula first. It is the vertical interval over the horizontal equivalent. So that's how we calculate our gradient. We calculate it as what? The vertical interval over the horizontal equivalent. Okay, so let's start first by explaining what vertical interval is. Vertical interval, okay. So our vertical interval now, to simplify it, let's explain our VI. We calculate it by looking at the difference in height. Okay, difference in height. Okay, in height. Okay, the difference in height. Okay, between two given points. Between two given points. That is our vertical interval. Let me give an example. I'll get to our paper. All right. The vertical interval, let's use the one that we use from when we're calculating distance. So we have got these two spot heights. We have got these two spot heights. Remember, we have got 1421 and 1412. We are going to use those two. 1421 spot height, 1421 and 1412. So we have got spot height a 1421 and 1412. All right. So a spot height, what it does is a height indicator on the map. A spot height is a height indicator on the map. So when you're looking at 1421, it means that at that point where we have got 421 is 1,421 meters. That's what it means. That's a spot height. It shows the height on the map. So that one where we have got 1421 is 1,421 meters. Where we have got 1412 is 1,412 meters. So it's showing height on the map. That's what it is showing. So a spot height, what it does is it shows height on the map. So we are given these two spot heights as height indicators on the map. So we are saying now, in order for you to find the vertical interval, it is the difference in height between these two given points. That is your 1421 and 1412. So when you're calculating your vertical interval, we are going to say 1421 minus 1412. So 1421 minus 1421. Remember, it's in meters, minus 1412 meters. So this is indicated in meters. It's height on the map, but it is in what? In meters. Let's calculate now. So 1421 minus 1412. So we have got this now. 1421 minus 1412. If you subtract what again, you are going to get what? 9 meters. So it means our vertical interval, which is the difference in height, is 9 meters. We have subtracted 1412 from, sorry guys, let me just correct here. Yo. Okay. All right. Sorry guys. It was just. All right. So are you following? So it means now we have got our vertical interval, which is the difference in height between two given points. We have got our spot height 1421 and spot height 1412. Are you following? Are you following, guys, how we calculated our vertical interval? Are you all fine? Are you all fine with how we calculated the vertical interval? Are we together, guys, on how we calculated our vertical interval? Are we together? Vertical interval is the difference in heights between two given points. That's what we have done. We have chosen two spot heights from our map. That is 1421 and 1412. So we have just subtracted. Okay, this is the spot height 1421 and 1412. Remember, this spot height is a height indicator that is shown on the map. So it shows the height on the map, height above sea level. So I've got 1421, this is in meters, minus 1412. So you take your highest height minus the lowest height. What is our highest height? Is 1421 meters. Our lowest 1412. So that's how you calculate your what? Your vertical interval. Are we together? Are we together? Are we together, guys? On how we have calculated our vertical interval is very clear. Okay, very clear. So our horizontal equivalent now, or horizontal distance. So our horizontal distance now, HD, is equal to map distance multiplied by scale. So the same way we calculate distance is the same way we calculate our horizontal equivalent or distance. The same way we calculate distance is the same way we calculate our horizontal equivalent or our horizontal distance. Are we together? Which means now, okay, are we together with the explanation that I've given now? our horizontal equivalent is this distance between the two spot heights, is the distance between 1412 and 1421 is the distance in between these two spot heights. That is our horizontal equivalent. The one we measure using what? The map distance multiplied by the scale. That's the formula. So we are measuring from 412 to 1421. That's what we do. Are we together? Remember, we already have, okay, let's use 2.6. I can see you want 2.6. Let's use 2.6. So the same calculation that we did for distance, let's do it now. So we have got what? 2.6 centimeters multiplied by, remember, we have to use the same unit of measurement. We are going to multiply by what? By 500, which is equal to 2.6 by 500. 2.6 by 500. We have got 1,300. 2.6 by 500. We have got 1,300. That's what we have. 2.6 by 500. We have got 1,300. Are we together? Which is what? 1,300 what? Meters. Are we together? Are we together? Okay. So we are now going back now to the formula. The formula for our gradient. That's where we are going back now. Okay. The formula for our gradient. Now, I'm going to rub off this. So it means now we have got 1421 meters minus 1412 meters, which is equal to 9 meters. So we are going back to our formula now. We are saying now gradient is equal to VI over HD. What is our VI? Our VI is 9 meters. What is our HD as calculated? Is 2, okay, let me just put it like this. 1421 meters minus 1412 meters. Okay, here 2.6 centimeters multiplied by 500 meters. Okay, I'm going to rub off here. Then if we subtract the VI, this is our VI, this is our HD. Here we are going to get 9 meters. There we are going to get 1,300 meters. Okay, are you following? This is our VI, this is our HD. Are you following? Are you following, guys? Are you following? Are you following? I don't want to confuse you. Are you following? Are we moving at the same pace? Are we moving at the same pace? Can I continue? Can I continue? Thumbs up if you want me to continue. Thumbs up. Thumbs up if you want me to continue. Thumbs up. Okay, I can see. Yes, 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 yes. All right. So we are going to divide both the VI and the HD by the VI. We are going to divide both the VI and the HD by the VI. So we divide by VI, divide by VI. Okay, which is 9 meters divided by 9 meters. 1,300 meters divided by 9 meters. Do you understand this stage? The stage that I've written down, do you understand it, or is someone confused? We divide both the VI and the HD by the VI, which is your 9 meters divided by 9 meters and your 1,300 divided by 9 meters. Do we all understand? Are you following? If you don't understand, go back up. Then you come to the stage where we are now. Do we understand? All right. Let me take you back. Let me take you back. Okay, I'm seeing some no's there. Let me take you back. So, we have started here, guys. Our gradient is equal to vertical interval VI divided by vertical interval, which is our VI divided by the HD. That is our formula. VI divided by the HD. So our vertical interval is the difference in height. We have got two given heights. That is 1,421 meters and 1,412. So the highest height minus the lowest height, difference in height for your VI. That's why we have got 1,421 meters minus 1,412 meters. That's how we got this 9 meters. For our horizontal equivalent, the same way we calculate distance, remember I had shown it just now, we measured the distance between our two spot heights, which is from here, here up to there, and we got 2.6 centimeters, and we want it to be in meters, obviously, because our VI is in meters. They have to use the same unit of measurement. So 2.6 centimeters multiplied by 500 meters. Our scale for topographical is 50,000, 1:50,000. We have just converted it into what? Meters. That's why we multiplied our 2.6 centimeters multiplied by 500, and we got what? 1,300 meters. Are we together now? Are we together now? Someone is saying, Prudy is saying I'm lost. Are we together, guys? Are we together? Are we together? Are we together? Are we together? Can I continue? Or you need more explanations? Can I continue? You need me to add more information? Why do we divide twice? Because we want to find, it's going to be expressed as a ratio. It's expressed as a ratio, your gradient. We have got the VI, okay? We have got your vertical interval is 9 meters, the difference in height. Highest height minus the lowest height, 9 meters. Then our distance, horizontal distance or equivalent, 2.6 centimeters multiplied by 500, we got this. So, remember our gradient is expressed as a ratio. So we divide here. That's why we are dividing. So now we are saying 9 meter, which is our VI. So it's VI divided by VI. And HD divided by VI as well. So it means we are going to have 1 here, then 1,300 divided by 9. (1,300) divided by 9. What do we have? 1,300 divided by 9. We are going to get 1,300 divided by 9. We are going to get 144 divided by 144.44. Okay. So we have got 144.44. So that is our gradient. 1:144.44. That's what we are going to get here. Okay, or we start writing as a fraction, or 1/144.44. The final answer is written like a ratio, which is 1:144.44. Or you can just write it 1:1.44. So that's how you can also write it. So it's expressed as a ratio. It's expressed as a ratio. That's how it is expressed. So this is our gradient now. Our gradient, what does it mean? When the gradient is less than 10, it means it's steep. When it's less than 10, it's steep. Less than 10, it means it's what? Steep. If between 10 to 15 is what? Is moderate. If it's more than 15 is what? Is gentle. So what it means here, this gradient is what? Is gentle, because it's 144. Are you following? Are we together here? Are we together? So that is gentle, it's more than 15. So that is the interpretation of your gradient. If it's less than 10 is steep, 10 to 15 is moderate, then it's above 15, then it means it's gentle. So the gradient there is gentle. It's gentle. Are we together? Are we together? Are we moving at the same pace? Are we moving at the same pace? Okay, are we moving at the same pace? Moving at the same pace. Thumbs up. I can see everyone understand. I can see everyone understand. Okay. Yes, sir. Yes, sir. Why do we calculate the magnetic guys, let's not mix things, guys. We are calculating gradient. Someone is already talking about magnetic declination. Let's not mix things. Let's not mix things. We are getting to that magnetic declination. One thing at a time, please. Because if you just mix things, then you are going to confuse other people. Let's stick to what we are doing. Gradient first, when we are done, we go to the next until we get to magnetic declination. Because someone is already asking about why do we calculate magnetic declination. Let's not mix things. One thing at a time, one thing at a time. So do you all understand how we calculate gradient? Do you all understand how to calculate gradient? Are we all fine with gradient? With map code, distance, and gradient, are we all fine with those three calculations that we have done? We want to move to area now. We want to move to area. Okay, thank you. So give me a thumbs up for the last time so that I can move to area calculation. Area calculation, thank you. Let's move on to area calculation. Sharp. So this is your gradient. So we are moving on now to the next. We have done this map code. We have done distance. We have done gradient. We are moving on to area now. Area calculation. Area calculation. So the first thing on your question paper, they usually give you this formula for area. They say area is equal to length multiplied by your breadth. This is what they usually give you on your question paper. But you have to know now that you multiply your length times scale and your breadth times scale. The correct formula that you use when you're doing your calculation is length multiplied by scale, in brackets, then your breadth multiplied by your scale. That's how you do it. So they usually give you only the formula that is your area is equal to length times breadth. But you have to know that you will multiply your length times scale and your breadth times the scale. Are we together on this one? Are we together before I start calculating? We are going to calculate the area of the red square on the topographical map. This one, that is what we are going to calculate. We are going to calculate the area of this. We are going to calculate here. We don't add, we multiply, we don't add, we don't add, we multiply. We multiply, we multiply, guys. We multiply, we don't add, we multiply. We multiply, we don't add. These brackets also symbolize multiplication. So there is no addition sign. It shows multiply when it's like this. It's just like saying multiplication, okay? Are we together? So the first thing, the first stage, are we fine with the first stage? Length times breadth. That's what you are given on your question paper. But you have to know that you multiply your length times your scale and your breadth times your scale. Are we together? So we want to calculate this. We want to calculate the area of this red square. That's what we want to calculate, the area of this red square on the topographical map. Area of the orthophoto. That is the area of the orthophoto on the topographical map. So let's measure now. So we have got 2 here. Let's measure. So you can see here, we are going to measure both sides first, then we write it down. From here up to there, what do we have? Can you tell me? How many centimeters there do we have here? Let's write the centimeters first. It looks like something like 4.4. Is it? Can you confirm? Is it 4.4? 4.3. I am seeing 4.4. So we have got 4.4. All right, sharp. Then let's measure the other side. Let's measure the other side. What do we have? Can you tell me what we have here? What do we have here? Is 3 point, it looks like 3.7. Can you confirm? 3.7 centimeters. Can you confirm? Is it 3.7? Is it 3.7? Thank you. So we have got 3.7 centimeters. So when you have measured, sometimes you are given the length of the, you can be given the length, then you have to measure the breadth. Or again, if you're given both the length and the breadth, then you have to multiply. So the longest, this is the longest name. When you measure, it becomes your what? Your length. This is the shortest. It becomes your what? Your breadth. Okay. Are you following? Are you following? So that's what we have. We have measured. We are assuming that we were not given the length or the breadth. We were asked to measure to calculate the area of the red square, area of the orthophoto red square on the topographical mode. So we are assuming that we were not given the unit for the length and the breadth. That's what we are working with. So we have measured it ourselves. The longest becomes the length and the shortest becomes the breadth. And remember, your area is always squared. Your area is always squared. We want to calculate this area in meters. Let's calculate the area in meters. All right? Calculate area in meters. Calculate area of the red square on the topographical map. In meters. Okay, so here's how we do it. We are going to calculate in meters. So we want to calculate in meters. How are we going to do it? Remember, we are using a topographical map. So we will say now, area is equal to what is our length? We are going to take 4.4 centimeters. Remember, we want our areas to be in meters, which means square meters. So if we convert the topographical map, 1 is to what? 50,000. This is in centimeters. In meters, 1 is to what? 500 what? Meters. So we are going to multiply this with 500. Why? Because we want our answer to be in meters. So we multiply by 500 what? Meters. Then we take the shorter side, 3.7 centimeters multiplied by 500 meters. Okay. Are you following? Are you following? Are we together? Are we together on this before I proceed? So we have got 4.4 centimeters, which is the longest side, multiplied by 500 meters, because we have been instructed to write our answer in meters. So it's going to be square meters. Okay, sharp. So let's calculate now. 4.4, let me get my calculator. I'm just checking it. So 4.4 multiplied by 500. What is the answer? 4.4 multiplied by 500, we get what? 2,200. Are we together? 2,200 meters. Okay? Which is 2,200 meters multiplied by. Let's multiply our breadth now. 3.7 multiplied by 500. What do we have? We've got 1,850. We have got 1,850. We have got 1,850. Let me use another color. This one is a little bit faint. 1,850 meters. Okay? We are not yet done. So we now have our 2,200 multiplied by 1,850. All right. So we have got something like this now. 2,200 multiplied by 1,850. All right. Someone is saying is the scale. We have converted the scale, the 50,000 into meters. That's why we have multiplied with 500 meters. We have converted the 50,000 into meters. That's why we have multiplied by 500 meters. Are you following? All right. So 2,200 by 1,850. We have got what? What do we have here? We have got 4,070,000. That's what we have, okay? That's what we have. So we have got 4,070, and this is always squared. Remember, this will be our answer. So from what I have done, I want you to take note. Check my length. It has got the unit of measurement. Our scale has got the unit of measurement. My breadth has got the unit of measurement. My scale has got the correct unit of measurement. My length, correct unit of measurement. My breadth, correct unit of measurement. And my answer as well, correct unit of measurement. Your area can give you about 5 to 7 marks. So you've got 5 marks there. Are you following? Are you following? Are we together, guys? We have used 500 because we have converted our 1:50,000 to meters, which is 500 meters. That's why we have multiplied with 500 meters. Is this clear? Is this clear, guys? Is this clear? Lekue is saying that I don't understand. Okay, no problem. We'll take you again. We'll explain. Some people are saying yes, 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 yes. Okay, most people understand. So let me explain for the last time. Let me explain for the last time. So, our area calculation. Remember, your area is always squared. Okay, we have said it is always squared, be it in centimeter or in kilometers. It is always what? Squared, your answer. So, what you are given on your question paper is this: length times breadth. That's the only thing that you are given. But you have to know that when you're calculating your area, you multiply your length with your breadth, okay? Your length with your scale. You multiply your length with your scale and your breadth with also your scale. That's what we have done. So what we did after is we went on to measure the area of the autofort of the red square, this one, on our topographical map. That's what we did. So we had two sides. The other one is 4.4, which is this one, 4.4 centimeters. The other one is 3.7 here. So that's how we got these numbers, 4.4 centimeters and 3.7. We have said, after you have measured, if you are not given any of these, that is your length and your breadth, you have to measure it yourself. But in some instances, you can be given the length, then you have to measure the breadth. Or you can be given both, then you just have to multiply. So if you are not given, you measure the longest side becomes your length, which is 4.4. The shortest becomes your what? Your breadth, which is 3.7. So calculate the area of the red square. Area of the red square now. It means your longest now, which is your length, 4.4 centimeters multiplied by 500 meters. Why are we multiplying by 500 meters? Because our answer has to be written in what? In square meters. So we can just multiply. We can convert our scale to meters right away so that you don't struggle. You understand? You can use 50,000, but here we are making your life easier by just using 500 meters. That's what we are doing. So it means you are going to multiply your 4.4 centimeters multiplied by 500 meters in brackets, then 3.7, which is your breadth, multiplied by 500 meters in bracket. If you multiply 4.4 by 500, you get what? 2,200 meters. If you multiply 3.7 by 500, you get 1,850. If you multiply these two, they will give you 4,070,000 square meters. That will be your answer. That will be your answer. Are we together now? Is it clear now? Is it clear now? I want to hear from you guys. Is it clear now? It's clear, né? All right. Is it clear now? Is it clear now? All right. Thank you so much. Is it clear now? I want to ask you guys, some of you, I think you are writing your economic geography. Is it tomorrow? Is it tomorrow? You're writing tomorrow. Do you want us to go on to magnetic true bearing, or we can continue tomorrow? I want to hear from you, because I don't want to disadvantage those ones who are writing tomorrow. I know most of you have already written your economic geography. Can we stop here today? Then tomorrow we start with true bearing. Can we stop here today? Then we start with true bearing tomorrow. I don't know. What do you think? You want us to continue? All right, we can continue, no problem. So let's continue. No problem, let's continue. So we are moving on to true bearing now. Is there anyone who doesn't understand, or we are all fine now? We are all fine. Let's continue today sharp. We are continuing sharp. So we are done now with area. Okay. I'm going to rub off this. So with true bearing, I'm going to explain first, then we can use the map. True bearing. We are going to do true bearing now. So I'm going to use some examples, 2 examples to make our life easier. I'm going to use 2 examples. The simplified one. I want us first to find direction from a fixed point. Then after that, I'll do the bearing now, so that at least we have an idea. Okay. Okay. Let's say we are given, before I start with true bearing, I want to talk about the distance from a fixed point as foundation for true bearing. Don't get me wrong, guys. I'm going to start by explaining the direction from a fixed point first. Then we can move on to true bearing. I'm using this as a foundation. Okay. So when you were in, I think in primary or part of grade 8, you were asked, okay, I want to do it like this. This is the foundation, please. I haven't started with the true bearing. I'm going to use this as a foundation. What is the direction of A from B? I'm using this as a foundation. I haven't started the true bearing. Okay. So identify. First, number 1, identify from and to. Let's assume our B is here and our A is here. So the question here is, I'm using this as a foundation, guys. I haven't started with the true bearing. I'm going to use this as a foundation. So the question is saying, what is the direction of A from B? So what you do when you want to find the direction now, the simplified version, what you do now is, number 1, you draw your cardinal points. Okay? Identify B is the from. This is the from. Okay? A is the to, which means you measure from. So what you do, you draw your line that passes through B. All right? You do your cardinal points. Okay? Which means you are going to have something like this. You are going to have something like north, south, west, and east. We are going to also further add the 8 cardinal points, which means this one becomes your northwest, northeast, southeast, southwest. So here, I'm talking about direction, guys. I've not yet started with the true bearing. I'm using this as the foundation. So, if you want to find the direction of A from B, you go first to B. Draw your cardinal points. You've drawn the 8 cardinal points. the next thing you join the 2 points, which means if you want to find the direction now, where is your A from B? Is in the northwest direction. So your answer there is what? Is northwest. So the concept of true bearing now is going to be done in degrees, but it was borrowed from this. If you look at it, it was borrowed from this. I'll explain now for you to understand why I'm saying it was borrowed from this. But this is showing direction from a fixed point. What is the fixed point? The fixed point is B. That's where we are calculating our direction from. North, south, west, east. We have added on the other 4 to make it 8 cardinal points. So what will be the direction of A from B? So A is the from part. So we draw our 8 cardinal points at B. Then we join the 2 points so that we can find the direction of A from B, which is in this instance we have saying is what? Northeast. That would be the direction from a fixed point. So the direction, the calculation of your true bearing is where some kind of borrowed from this. Okay, let's see how it's done now. Okay, I'm going to use the same concept. So I'm going to rub off this. Okay, do you understand this first before I move on to true bearing? I've used this as the foundation. I'm on YouTube. Yes, I'm on YouTube. Do you understand this foundation, guys? I have just started with this as the foundation. Direction from a fixed point. Do you understand? I want to move on to true bearing now. Are we all fine? Because I wanted us to have a sort of a foundation so that you understand. So this is direction from a fixed point. Okay, thank you. Let's do true bearing now. Okay. So we want to calculate the true bearing now. So I'm going to start by demonstrating. Then after that, we go to our map. We use a map. So I'm going to demonstrate first on the board. What is the true bearing of A from B? That's what I'm going to do. I'm going to explain using this. Then we can get an example from the map. So I want you to pay attention now. I've got everything that I need here. I've got this. That is your protractor. So the first thing is saying, what is the true bearing? What is the true bearing of A from B? Which means from the information that we are given, this is the true. Identify. So the first thing that we do is we identify. Step number 1. Identify the 2 points. The 2 points. Okay. We have got A and B. I'm going to write them. Then number 2. Identify the from and to point. Okay. Assuming that, okay, identify the 2 from and to point. Okay. Then number 3, what do we do? Draw a perpendicular line that passes through the from point. Draw a perpendicular line that passes through the from point. Are we together? Okay. Number 4, join the 2 given points. Once you have done that, measure the true bearing from the true north, in a clockwise direction. In a clockwise direction. So these are the steps. So what I'm going to do, I want you to understand this first. I'm going to demonstrate it, okay? So the first thing is identify the 2 points. That is, this is your to, this is your from. So we have done that. I'm going to demonstrate it, okay? Then after you have identified the 2 points, that is your first step. Identified the 2 points, we have done that one. Identify the to, the from, and the 2 point, which means this is your B, this is your what? Your A. Then after that, draw a perpendicular line that passes through the point, the from point. So you are drawing now, you draw a perpendicular line that passes through the from point. Then from there, you join the 2 given points, then measure the true bearing from the true north in a clockwise direction. These are the stages that you use. I'm going to demonstrate. I wanted to write this first before I start. So the first thing that you do, you identify the 2 points, you identify the from and the 2 point, you draw a perpendicular line that passes through the from point, join the 2 given points. I'm going to do it now, demonstrating now. Okay, I'm going to rub off and demonstrate now. So what we are saying now, are we fine with these notes that I've written on the board, the stages? I want to start doing it now. I want to start doing now. Are we fine with the notes that I've given them? That is, you identify the 2 points, identify the from and the 2 point, draw a perpendicular line that passes through the from point. I'm going to demonstrate now. After demonstrating on the board, then we can use an example from the map. Sharp. Okay, sharp. Let's do it now. So what we are simply saying is, okay, assuming that we have got our B here and we have got our A here. These are the 2 given points. So the first thing that I have said is identify the 2 given points. This is your A, this is your B. So your B here is the from, which means that's where we are measuring from. This is the 2. Okay. So I have said that draw a perpendicular line that passes through B, which means you are going to have something like this. You are going to have something like this. This is a line that passes through the from. So you are going to have something like this. We do this so that we can identify our true north where we are measuring from. So this is our true north. Okay. That's where we are measuring from. So we draw this line, the perpendicular line that passes through the from, which is B, so that we can identify our true north where we measure the true bearing from. Then after that, I say, join the 2 given points. We have done that now. We have joined the 2 given points. So with true bearing, we measure from the true north in a clockwise, which means what we want is this. This is what we want in degrees from the true north. We measure clockwise from the true north. So number 1, we identified the from and the 2 point. We have got B from, we have got A 2 point. We have identified those 2, number 1. Number 2, we have drawn our line, a perpendicular line that passes through the from point. We are doing this so that we can identify our true north. That is where we measure our true bearing from. But in a what? Clockwise direction, which means we are going to measure like this. So this is what we want to measure now. Using a protractor. We want to measure in a clockwise using a protractor. Up to date. All right. Do we all understand? First, before I move on, do we all understand? Is it clear? Before I proceed, is it clear? Is this clear before I proceed? Is this clear? Can I proceed? Can I proceed? Can I proceed? Guys, don't forget to tap the screen. Don't forget to tap the screen. Can I proceed? Okay, so we are saying now, we have number 1, identify the 2 points. We have identified the from and the 2 points. That's what we have done. We have drawn the line that passes from our from point, which is B. We have written or identified our true north where we measure from. So this is the angle that we are measuring, which is our true bearing. So we have got the protractor. This is the protractor that I'm going to use. The protractor. You place it like this. Can you see? We are measuring from the true north. Make sure it's exactly at where the B is. We are measuring from 0 here, from the true north. 0, it goes up. So it means this one is going to give us 180 degrees. So we'll have what? 180 degrees plus. Remember, we have to measure this side as well. So straight line gives us 180 degrees. We take our protractor again. We place it here. What are we going to get now? We are measuring from here because we are ending here. So we measure from here 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. We are somewhere around 115. That's where we are. So we are going to add. We are going to add 1150. So here it's 115 degrees. Here is giving us 180 degrees. So the true bearing of A from B is going to be our 180 plus the 115 that we've measured from here up until there, plus the 115. So if you add 180 plus 115, what are you going to get now? You are going to get something like this. 180 plus 115. You are going to get 295. That's what you are going to get. 295. 180 plus 115. So you get what? 295 degrees. That will be your true bearing. Are we together? Are you following, guys? Are you following? Are you following? Are we together? Just give me a thumbs up if it's clear. Is this clear? So it's the same thing that you do on your map work. We are going to use a map now. Undisputed, you are saying no. Come on, guys. This is the easiest thing. I can see most of you have said it's fine. Let me go through it again for the last time, what I've written down. Then we can see. But this is clear. The way I've explained it, guys, it's crystal. It's clear. Let me do it again. So we are saying, guys, that's why I started with direction from a fixed point, because I wanted you to have a better foundation. We are saying now, when we are calculating the true bearing, we are given something like this. What is the true bearing of A from B? These are the 2 given points. So we have said, identify the 2 points. Well, that's what we have done. We have identified our A, we have identified our B. Okay. So you measure your true bearing from the from given point. So our from given point in this instance is B. A from B. That's why we have identified our B here. And after we have identified our B as the from given point, we draw a line that passes through B. We are doing this so that we identify our true north, where we measure our true bearing from in a clockwise direction. So this is the line that we have drawn, a perpendicular line. We have identified our true north. We are now measuring from A to B, which means this is the angle that we are measuring. So you take your protractor, you place it like this. A straight line gives you 180 degrees. That's why we have got this 180. So a straight line gives you 180 degrees, okay? Then we move on to the other side now. Here, what did we get? We measuring from here. So from here up to there, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 115. So we are saying from here up to there is 115. So we are adding the 180 plus 115. This is how we got the 295. That's how we got the 295. We are measuring in a clockwise direction. We have identified our from and the 2 part. That is your true bearing, boys and girls. Is it clear? Is it clear? Is it clear? I think this is crystal, guys. I've explained it in the easiest way. I've explained it in the easiest way. So I'm going to use an example now from the map. I'm going to use an example from the map now. That's what I'm going to do. An example from the map. Of course, what I'm going to do, I'm going to show you two given points. I'm going to use these two spot heights. Remember the one that we have used previously for our gradient. So we are going to calculate our true bearing of spot height 1412 from spot height 1421. So our from spot height is 1421, which means it's here. This is our from 1421. This is our from. So what I'm going to do, let me do it now. So I have drawn a line that passes through our spot height 1421. This is the from part. We are measuring the true bearing of spot height 1412 in block A1 from spot height 1421 in block A1. That's what we are doing. So I have identified the from. My from is 1421 here. So I've drawn a line that passes through 1421. Do you understand this, guys? That's what I've done first. I have identified the from part, which is 1421, and I've drawn a line that passes through 1421, which is the from part. Do you understand this, guys? I want to move on. Bonolo, come on. Come on, come on, come on, come on. I've drawn this line. This is the perpendicular line. I've got two given points. I've got spot height 1421 and 1412. So my 1421 is the from. So I've drawn a perpendicular line, like I said, that passes through 1421. That is the first thing. So the next thing, what I'm going to do is I'm going to join the 2 points. That is 1421 and 1412. Okay, I have joined the 2 points. Can you check? I've joined the 2 points. That is your 1412 and 1421. 1421, that's where I'm measuring from. I have identified my true north. I have joined these 2 points, 1421 and 1412. Are we together? Bonolo, thank you so much. Thank you so much. Thank you so much. I'm glad if you understand. Are you following, guys? So I've drawn a line that passes through my 1421, which is the from point. I have joined the 2 spot heights. That is 1421 and 1412. Are you following on this one? Are we moving at the same speed? Give me a thumbs up if you are following. Give me a thumbs up if you are following. I'm going now to measure my true bearing from the true north in a clockwise direction. I'm going to measure my true bearing from the true north in a clockwise direction. So I'm going to measure from here. Can you see? From here up to there. That's what I'm doing from here up to there. That's what I'm going to do. That's how I'm going to measure now. From, you see, clockwise from the true north here up to there. Can you see here? I'm measuring this angle in a clockwise direction. I'm starting from my true north. Are you following? I'm starting from my true north. I'm going to measure in a clockwise direction from here, from the true north up until there, where they join. Are you following? Are we together at this stage? Are we together? Are we together? Thumbs up if we are together. Are we together? Are we together? Sharp, I've seen one. I want the thumbs up from Bonolo. Thumbs up, thumbs up, thumbs up, thumbs up, thumbs up, thumbs up. Okay, okay, okay. Bonolo, I'm waiting for you. Because remember, you once said that you were confused. I want to make sure. Bonolo, Bonolo, I'm waiting for you. I'm waiting for you. Okay, Prudy, that's fine. Bonolo, Bonolo, I'm waiting for your confirmation. All right. So I'm going to take my protractor now to measure. Okay. Yeah, I think we are fine there. Let me check my protractor. I'm looking for my protractor now so that I can measure. I'm looking for my protractor, guys. Just a minute. Where is my protractor? I had it just now. It just disappeared. I'm just getting my protractor. Where's my protractor? Just a minute, guys. I'm looking for my small protractor. I had it just now. All right, I've got it. So this is my protractor now. Okay. So we are saying now from here. All right. All right. So can you see now? I'm exactly there. Can you see here? Just put it down a bit. Can you see the straight line is giving me 180? Just push it this side a bit. Can you see the straight line is giving me 180? The straight line is giving me 180. Give me the pencil. Can you see the straight line is giving me 180? All right, I'm measuring from here, from the true north 0 up until 180. It's a straight line. So it means I'm going to get what? 180. Let me write it somewhere. 180 degrees. Then on the other side, can you check now? I'm going to put my protractor here. Then I'll measure now from here, from the bottom. Can you check here? 0, from 0. 0, 10, 20, 30, 40. Is somewhere around 45. Can you see? Somewhere around 45. Can you see? From here, 0, 10, 20, 30, 40, somewhere between 40 to 50. Can you see? So I'm going to add, let's say 45. Let's agree on 45. I'm going to add the 45. So I've got 180 and 45. That's what I have. That will give me my true bearing. 180 plus 45. 180 plus 45. Can you see my answer? That will be my true bearing. Are you following? Are we together? That will be my true bearing. What I have just done is I have measured in a clockwise. I have measured from here up to there. So this gives me 180 straight line. This have given me 45. So are we together? Is this clear? Is this clear, boys and girls? Is this clear? It's the opposite side. No, it's not the opposite side. We are measuring. This is clockwise. We measure from here going this side. We don't measure like this. Is anti-clockwise. Clockwise, we measure like this. It's not the opposite side. We measure in a clockwise from the true north. This is our true north. We measure from here going like this. It's not the opposite. We measure in a clockwise. Are we together? So that's how we got this answer. Are we all fine with true bearing? We want to move on to magnetic declination. If you are fine with true bearing, we want to move on to magnetic declination. Are we all fine with true bearing? Okay, are you all fine with true bearing? We want to move on to magnetic declination. Okay. Can we move on to magnetic declination? A thumbs up if we are all fine. Sharp. We are all fine. I can see. There's no objection. All of you are fine. So we are moving on now to magnetic declination. Sharp. All right, thumbs up. Moving on to magnetic declination now. Sharp. So let's keep in mind, we are going to use this answer that we have here, which is 225. So I'm just going to write TB there, 225. Ne? Okay. We are moving on now. I'll say true bearing is equal to 225 degrees. So we are moving on to magnetic declination. All right. All right. Magnetic declination. All right. So I'm going to start with the basics. Magnetic declination, we calculate it because it changes every year. We calculate it all the time because it changes every year. So the information that we have in as far as magnetic declination is concerned is here. We are going to use the same map of Alwal. This is the information that we'll use. Can you see that? Where it's written magnetic declination. This was for 2017. Can you see that? Then you also have the other information, mini annual change. So the information that you'll use for your magnetic declination, you will get it from the map. You will get it from the map. The information that you use for the calculation, you'll get it from the map. The information that you use to calculate your magnetic declination, you get it from the map. So we usually calculate for the current year, which means we are going to calculate the magnetic declination for 2026. So I'm going to write the stages, then we are going to follow those stages. So the first thing that we have to do is we calculate the difference in years. Okay, that is the first stage when you're calculating the magnetic declination. Or before I get you to that, okay, we always calculate to the west. Okay, we always calculate it to the west. If it's to the west, if magnetic declination is to the west, we add. If it's to the east, we subtract. Please, this is very important. But however, from our paper, it is always, in South Africa, we are always adding. We are calculating it to the west. So if it's to the west, we add. If it's to the east, we subtract. So how do we calculate magnetic declination? So we calculate for the current year. The first stage, number one, we say difference in years. Difference in years. That is our first calculation. We use the current year. So we use the current year. Okay? So it's current year minus year on the map. On the map. So what do I mean by that? The year that we'll use on the map is what? If you can check on this map, which year do we use? Which map do we use? Okay. Which map do we use? Which year do we use here? 2017, that's correct. So we use this year here at the top, which is showing the magnetic declination. That's the one that we use. So it's 2026 minus 2017. Okay. So the difference in years here is going to be 2026 minus 2017. What is the answer? 2026 minus 2017. What is the answer? So that is the first stage when you are calculating. Okay. 2026 minus 2017. Okay. 2026 minus 2017. So we have got 9 years. Please make sure you write it in full. 9 years. You have got your 9 years. The next thing, write down your mini annual change, which is here. Can you check here? At the bottom, written mini annual change of 9 minutes westward. You write it down. 9 minutes westward. That is your mini annual change. You have got your mini annual change. Write it down so that you don't mix things. Mini annual change. Mini annual change. Your mini annual change is the 9 minutes W or westward. Okay, so with this information now, this is we are getting the 9 minutes from here, 9 minutes westward there, 9 minutes westward, that is our mini annual change. So we are going to calculate the total annual change, okay? That's what we are going to calculate now. Total annual change, that is stage number 2. Total annual change, which is your difference in years, that is 9 years multiplied by the mini annual change, which is 9 minutes westward, or W. Okay, are you following? Are you following here? We are now saying 9 years, which is the difference in years, multiplied by the mini annual change, which is 9 minutes westward. And what do we get? We get 81 minutes westward. What do we do when we get 81 minutes westward? What do? We do not leave it like that because it's above 60 minutes. So we convert it to degrees. Remember our rule, our 1 degree is equivalent to 60 minutes. So if it's above 60 minutes, like the 81 we have, we don't leave it like that. We have to change it to degrees because it's above 60 minutes. Our 1 degree is equivalent to 60 minutes. So we are saying now, how many 60 minutes do we have in 81 minutes? We have got what? 60 minutes. Then we'll be left with how many minutes? So it's a matter of just saying 81 minus 60. What will be the answer then? So it means we'll have here, if we convert this, we are going to have 1 degree. Then we'll be left with how many minutes? 81 minus 60. 81 minus 60. We are going to be left with 21 minutes. Ne? 81 minus 6, 21 minutes. So 1 degree, 21 minutes westward. So that will be our total annual change. That will be our total annual change. We are not yet done. Do you understand this stage? Do you understand this stage? So we have started first with, we are calculating the current magnetic declination. The first thing, the difference in years, which is the current year. We calculate the magnetic declination for the current year. The year that we are in, 2026 minus 2017, 9 years. We write down your mini annual change, which is 9 minutes westward. Okay? So we are now going to use our difference in years and our mini annual change to calculate the total annual change. That is 9 years multiplied by 9 minutes westward. That's how we got the 81 minutes westward. We do not leave it like that. Why? Because it's above 60 minutes. We have to convert it to degrees. That's how we got the 1 degree, 21 minutes westward. So we have got 1 degree, 1 degree, 21 minutes westward. Are you following? Are we together? Are we together, guys? Are we together, guys? Thumbs up if you understand. Thumbs up, thumbs up, thumbs up. If we are together, thumbs up, thumbs up, thumbs up, thumbs up. So we are now going to calculate the current magnetic declination. Don't be saying no. Okay, we are going to calculate now the current magnetic declination. Okay, so we are calculating now the number 3. Then current MD. So what we are going to do now, remember when we're subtracting the difference in years, we took the MD for 2017. We are going to take that, what we have here, which is what? 24 degrees. We are going to take this 24 degrees, 43 minutes west of true north for 2017. Then we add with the total annual change. That's how we will get the what? The current magnetic declination. The magnetic declination for the year that is shown on our map, that is for 2017, which is 24 degrees, 43 minutes west of true north. Then we add the total change. It will give us the current magnetic declination. Are you following on this one? Is there anyone confused? So we are taking the magnetic declination on the map there that we subtracted from the current year. Then we add the total annual change, which is 2443 minutes. So we are saying 24 degrees 43 minutes west of true north plus 1 degree 21 minutes W. Do you all understand this stage? Do you understand this stage? Do you understand this stage? Don't worry, guys. This live, I'm going to share it on my YouTube channel. You can always go there and check. So we are saying current magnetic declination is what we have here from the year that we subtracted from 2026, which is 24 degrees 43 minutes west of true north. Then we add 1 degree 21 minutes westward. Are we together? Are we together? Are we together? Then we are going to add the degrees and the minutes now. What do we have? 24 plus 1. 24 plus 1 will have 25 degrees. 43 plus 21. 43 plus 21. 43 minutes plus 21. 43 plus 21 minutes. We have got 64 minutes. Okay. 43, 64 minutes. Which means we have got what? 64 minutes. Here now, remember, it's west of true north. So we can't leave the 64 in minutes because it's above what? It's above 60 minutes. So we are going to take the 60 minutes from 64 minutes to add a degree on 25. So it becomes 26 degrees and 26 degrees 04 minutes west of true north. That would be our answer. That would be our answer there. Are you following? So our answer there, the 64 minutes is above 60 minutes. So we are going to convert it into degrees. So from the 64 minutes, we have got 1 degree 4 minutes. So we add the 1 degree to the 25 that is there to make it 26. So our final answer for the current magnetic declination will be 26 degrees 4 minutes west of true north. That will be our answer there. 26 degrees 4 minutes west of true north. So for today, I'm just doing the calculation. Then I think we'll have a time when we'll use the past paper. But I just want us to understand the concept first. So that's what we are doing. I want you to understand the concept first. So are we together, guys? Give me a thumbs up if you understand how I got the final answer there for the current magnetic declination. If you understand, okay, I can see. Someone is asking about the marks. Don't worry, I'll explain now. It can take from 5 to 7 minutes, 7 marks. Okay, sharp. So we are saying you get a mark for this. You get a mark for the multiplication here. You get a mark here. You get a mark there as well. You get a mark here. That is 1, 2, 3, 4, 5. Then you get 2 marks here. It's about 7 marks. It's about 7 marks. You get about 7 marks. We are not yet done. Okay, this one, okay, I think I've given, let me give one here, okay. Let's calculate our magnetic bearing now. Magnetic bearing is equal to true bearing plus MD. That is your magnetic bearing. We are not yet done. So you have got your 04. Yeah, that's correct. The 04 or just 4 minutes is the same thing. Bonolo is just 4 minutes. You can say 04 or just 4. It's 25, but you are adding. Remember, we have got 25 degrees 64 minutes west of true north. So we are saying your 64 minutes is above 60 minutes. So you convert it to degrees. You will have 1 degree 4 minutes. So the 1 degree will add to the 25 to give you 26. That's how we are getting the 26 degrees 4 minutes west of true north. So for your magnetic bearing now is true bearing plus magnetic declination, which is your 225 that we got as our true bearing. 225, which is your 225 200, I want darker color, all right, which is 225 degrees plus 26 degrees, 4 minutes west of true north. All right, so if we add 225 plus 26, what do we get? What will be our magnetic bearing? 225. What will be our answer there? Total minutes was 124. No, it was not one. It was 1 degree. 1 degree, 24 minutes. Happiness, you didn't read it nicely there. It's 1 degree. 1 degree, 21 minutes westward. It's not 124. 1 degree, 21. 1 degree, 21. Where did you get, guys? We started off, remember, we started off with the true bearing, guys. We started off with the true bearing, remember. We calculate the true bearing, the magnetic declination, now the magnetic bearing. So it's a continuation. Remember, when we calculate our true bearing from the map, we go to 25. Remember, when we calculated our true bearing from the map, we got 225 degrees. So that's where it came from. Remember this. Remember this. We calculated this. That is our true bearing. Plus our magnetic declination, which is this. So if you add these two, you are going to have 251 degrees, 04 minutes. Your magnetic bearing is not given any unit. You just write it like that. 251 degrees, 4 minutes. You leave it like that. You don't write it as a westward of true north. You just write it as 251, 4 minutes. You leave it like that. Magnet bearing, you don't write it as west of true north. You just leave it like that. So are we together? Is it clear, guys? Is it clear? Is it clear? I hope it's clear now. It's clear now. It's clear, eh? I think it's fine now. Is there anyone confused? I think we have done justice on that part. No, I think, guys, for today, guys, I think we have done justice. We can continue the map calculations tomorrow. Tomorrow, same time at 8 o'clock. Unfortunately, there was a technical problem. I couldn't stream on YouTube as well. So are we together, guys? Are we together? I think this is fine for tonight. You need time to rest. Tomorrow is school time and also need to start other subjects. So let's give that time, the time for you to start other subject. I think we have done a lot, guys. We have done a lot from map code, distance, gradient, area, true bearing, magnetic declination, magnetic bearing. So thank you so much, guys. Thank you so much. I really appreciate. So we start first with our map calculations. Then we move on to map interpretation. Then at some point, I think I need about 3 days for Mapwork only. Then on Wednesday, I think we'll be doing GIS. We'll have covered Mapwork. Then we start with our mid-latitudes, with climate and weather, mid-latitude, tropical cyclones, your subtropical anticyclones, your valley climates, and your urban climates. That's what we'll do. So we are going to do it by stage, starting with paper 1 first. So Mapwork first. So we have done enough for today. Map code, distance, gradient, area, true bearing, magnetic declination, magnetic bearing. So tomorrow we start with vertical exaggeration. We talk about intervisibility. That's what we'll do tomorrow. After that, if time permits, we can also start with map interpretation. So I hope, guys, you understand what we have done so far and you don't have any challenges. Please practice this. Mapwork needs practice. It's possible, guys. You can totalize Mapwork. I'm telling you, it's very possible. You can totalize Mapwork. You can actually totalize Mapwork. I'm telling you. If you look at the structure of your paper, if you can have 48 out of 60, climate and weather, geomorphology, 48 out of 16, and 24 out of 30 on your Mapwork, already you have maintained an 80%. So my advice is, if you can master Mapwork, I'm telling you, if you can get your 30 out of 30 on Mapwork, it's possible. or 28. If it happens that you don't perform well in climate and weather and geomorphology, you can always borrow some marks from there to maintain your 80%. So let's make sure that we totalize in this prelim. Let's make sure that we totalize the map work. It's possible. It's possible. You can totalize map work. Once you master the calculation, the interpretation, and GIS, I'm telling you, it's possible. You can actually totalize the map work. That is what we want to try and achieve on this prep. If you can be with me, let's push, let's push, let's push, let's push. Map calculation. Thank you so much, guys. I hope you enjoyed. I hope you managed to understand some of the concepts maybe that were difficult to you. I think we have done justice on this one. Thank you so much, guys. Have a blessed evening. Have a blessed evening. I'll see you tomorrow, same time. Continuation of part 2, Mapwork Calculations. Continuation of part 2, Mapwork Calculation. Thank you so much, guys. Have a blessed evening. For those ones who are writing tomorrow, go and write your economic geography. We have done justice on that one. I'm 100% sure you pass it as well. I'm 100% sure that you pass it. Thank you so much, guys. Have a blessed evening. I'm going to show this on my YouTube channel. Please show my share my TikTok profile. Share also my YouTube channel. I need more subscribers on my YouTube channel. As many as possible. Please, please, please share the YouTube channel. Please, it's on my bio on my TikTok. You can see the link for the YouTube. Share with your classmates. Please, please, please share it, share it, share it, share it. Thank you so much. Have a blessed evening, guys. I think this takes us to the end now. Tomorrow, we start with our vertical exaggeration. Then we do intervisibility. We take it from there. But I think we have done most of the calculations from what we have done. Thank you so much, guys. Have a blessed evening. Have a blessed evening. Thank you so much. Thank you so much. Thank you so much. So this is what we have done. We have done our map code, distance calculation, gradient, area, true bearing, magnetic declination, and magnetic bearing. This is what we have concluded with. If it's to the west, we always add, and to the east, we subtract. You never know, they might give you a question where you are supposed to calculate to the east, so know that you have to subtract. I think that's all, guys. Thank you so much. This takes us to the end of our live. Thank you so much.